kind of, but you need a combination of all other stuff. So chain rule, when do we use chain rule? The chain rule is used for taking derivative of a composite function. So taking derivative of composite function. What is composite function? Well, it looks like this. H of x equal to f of g of x. Like this. If you come to this far on math classes, you should learn about composite function. It's called also, in algebra 2, they call it the Fogg function of g, or could be Gauss, could be g of f, right? So at first, if you have, let's say if today I have h of x is equal to x squared plus 1 to the 4th power, what will be the f of x and what will be the g of x here? Okay, so let's ask Daniel. What do you think if I have h of x equal to x squared plus 1 to the 4th? Now, what will be g of x and what will be f of x? Exactly, good job. So g of x is equal to x squared plus 1, and f of x is equal to x to the 4th. Very good. Okay. Let me give you a couple more. How about h of x equal to root x squared plus 1? Chase, what do you think is going to be g of x, and what do you think f of x here?
G of x be just x squared plus 1. F of x be square root of this.
Perfect. Okay. So what will be, let's say h of x equal to sine of 6x. Nathan, can you tell me what's f of x and what's g of x?
F of x would be f of x would be sine and
Sine what? Just sine?
x.
Sine x, good. What's g of x?
6.
6x. Not just 6, because 6x. You're going to replace that x with a 6x. Yeah, I can see why you think it's 6. But in this case, if it's sine of x, if I plug in x if we replace as a 6x, then it's going to be sine of 6x. Does that make sense?
Yeah.
All right. So let's give you a definition of chain rule now. The most popular one is if you have f of g of x, and we're going to say this one is taking derivative of this. If I take a derivative of f of g of x, there are 2 layers. First layer is going to be this layer. Second layer is going to be this layer. Okay, imagine you have an onion or a Russian doll. You guys ever seen a Russian doll before? Like you take it out and there's another doll inside and take another doll inside. It's kind of like that, or like kind of onion when you peel the onion. First of all, there's the outer layer, right? So it's going to be f prime of the inside still intact. Like inside still intact is going to be g of x here. It's still intact here. And times the g prime of x. So you're taking derivative of each layer, but inside layer is still inside. It's not going to be outside here. So this is a definition of this. So this is the outer layer, and this is the inner layer. Now, when we don't go to trig, it might have inner of inner. So you have to be careful. So let's just say if I take a derivative of this. But don't get confused between f of a g of x and f of x times g of x. So let's talk about previous what we learned. We learned the f of x times g of x. This is different. If I take a derivative of this, it's different than f of g of x. Even though it looks very similar, but it's not the same. So in this case, it's going to be f prime of x times g of x plus f of x times g prime of x. This is called product rule. So this is not a chain rule. This is product rule because this is f of x times g of x. Two functions times each other. The other one is function within each other. Okay. Also, I can take a derivative of low d high, high d low. This is what we learned before. I'm just write it down for you. What kind of rule we have already learned. So low d high minus high d low, and a lot of people on the test, they forgot the low low. Okay, this is a quotient rule. Now, but today is f of g of x, not
Sorry.
f of x
Sorry,
times g of x.
what's the label for the fx times gx?
What is it?
The example is the one above quotient.
It's called product rule.
Thank you. It looks like pistachio.
I guess you can see that. Okay. Now we're gonna start taking derivative of this. I'm gonna give you the first function. I say, hey, is it possible for you to take a derivative of, let's just say, 2x minus 1 to the 4th power. Now I want to take a derivative of this. This is the first time I have something to the 4th power. And normally, most of you guys can think says, oh, okay, I'll just expand this. It's gonna take a while, but I'm gonna expand this using a Pascal triangle or binomial expansion. But here's the truth. Is you gonna get the same answer? Yes, absolutely. It's in the polynomial form, it's not in the factor form. But it's definitely wastes a lot of time. So what we're gonna do is we're gonna take a derivative of this using chain rule. Now also, when do you use chain rule? So when do you use chain rule? You might want to notice that too. So when do you use chain rule? When to use chain rule? Basically, if you have a parenthesis, of other power than 1. So this is power to the 4th, so it's other than 1. Is that okay? So what I'm going to do is going to take a derivative of this. There are 2 layers. First layer is there. Second layer is here.
Find the derivative of this thing. This will be this. Okay, so I get the problem.
So 4. So I color code this for you. So this is the 4 times 2x minus 1 to the 3rd times the derivative of the inside, which is 2, which is you also can name it 2x minus 1 to the 3rd. And that's it. Super easy. Taking derivative of that, it's very, very easy. Am I doing okay? So you're gonna take a derivative of one of them. Yes. How do I do what?
Well, simple. He treated the 2x minus 1 like an x, so since it's to the power of 4, you put the 4 in front, remove one of the exponents.
Oh, okay.
Because the thing is, it is an x. It's just we know what the x is. It's a bunch of other stuff, including an x.
Okay, that's a very good explanation. Yeah, it seems like I did power roll, but I also did power roll. I also take a derivative of the inside as well.
Yeah.
So the derivative inside is 2x minus 1. Take a derivative of 2x minus 1 is 2.
Treat the whole thing times one thing, and then you multiply that times the derivative of the inside.
Okay, good. So,
How does it work for like stuff with 3 layers?
okay, so 3x minus 2x squared to the third power. I want you to take a derivative of this and check with each other once they get done. Once you get done, check with your friends, see what they get, and see if you match up. Now, don't be afraid to tell me what kind of mistakes you make.
No, I screwed that up. That's supposed to be 3 not 1. Hold on, I'm not done.
Yeah.
That's very creepy. How your ankle can be all the way like this and then on the floor? No, what are you doing before? You were like,
No, this is what I ended up getting.
no, you were like
Well,
this.
yeah.
No, the other way. No, yeah.
3 minus
How your ankle can rotate that much?
What happens if you
What?
So you just treat this as one object with the 3 on the outside, treat that as 2. Then you find the derivative of the 3x, that's just 3x, 4x. And then you multiply that times the constant, giving you 9, 12x. And
I'm like, I was watching him. I'm like, how did?
yeah. That's why if you think you don't distribute, it's just way faster. It's answer 9 minus 12x times 3x minus 9 minus 5. You treat this as one thing. You move the 3 out to the outside and change the exponent to a 2. So then you put this on the other side over here. The 3x changed to a
Okay.
3, a negative 2x.
It looks good.
2 down to 4x.
I think it looks good.
That's
Huh?
constant.
All right. Now,
I don't know why. I don't know why it's working so well.
is y prime. So first layer, second layer. So I'm gonna take a derivative of the first layer. So it'll be blue. So it'll be 3 times 3x minus 2x squared to the second. And then I have to take a derivative of the black layer, which is here it's gonna be 3 minus 4x. Now, some people distribute this if you want to, but I won't distribute it. I'll just leave it as a factor form because I think factor form is better because it's easier to find horizontal tangent, right? So that's it. I'm done. It's very, very easy. So now I'm going to give you another one. How about f of x equal to, sorry, it's going to be to the third of 1 minus x squared to the second.
Okay. Wait, can we work together for this?
No, I need you to work it out by yourself and then check it with each other.
That's just,
So a bit your double joint on your ankles, shoulder, what else? So your knee is double joint as well? The tongue?
One over root 3.
Can you rotate all the way to the back?
1 over cube root.
Like people can do like jump rope with their arm. You try that? That is really weird.
I got -4 over 3 cube root of -1 minus x. Sorry, x1 minus x.
I don't know yet. We can check with each other. Okay, so check it. Just wait for him. Yeah, I'm patient.
Hey, do you have the answer yet?
Work it out.
I know, I found the answer. I'm just trying to check.
I'm streaming, so only here is your voice.
That's
Andrew is
the problem.
watching. There's only 2 there. Ashton, you done? All right, so for you guys, okay, yeah. Okay, so for you guys in class, please understand something.
Yeah, I guess so.
Don't be afraid to make mistakes. Mistake is good in class. Mistake is bad, like when you're taking a test. So right now, for me, like a lot of you guys are so afraid of making mistake and you stopped. No, just go all the way out, do as much as you can.
Damn it, you're right. But
Yeah. So a lot of time is you gotta learn to go ahead and make mistake, as much mistake as possible, and then you start reducing those mistakes. You cannot just stop halfway. You say, I don't know this right, and you stop there, because I'd rather you make mistake all the way through, and then go back to fix, whatever you need to fix. Because it's like you're learning how to play a piece of piano. I mean, on the first phrase, you stop. You say, "Oh, I don't know if I play it right," and you just stop at the first line, and you don't keep on finishing. You want to finish it, and just make as many mistakes as possible, and that's fine because you go back and fix individual mistake. Now, if you just only focus on first line, then you make mistake and you stop. You say, "Oh, I don't get past that, and I don't know. I don't want to go further." No, it's okay for you to actually to make all the mistake you can on the first try, and then go, for fixing everything. So in this case, I will change this to 1 minus x squared to the 2 over third power. It's called the definition of radical. So actually, you just use the definition of radical here. And then I just change it to 2 thirds. So now it becomes only 2 layers. Not 3 layers. It's 1 layer here. And 1 layer here. And then so now I'm going to take a derivative. So if I take a derivative, I always remember it's f prime of x. And the first layer is going to be 2 thirds of 1 minus x squared to the negative 1 third. The second layer is going to be times negative 2x. Take a derivative of 1 minus x squared. And then it's going to be negative 4x over 3 times 1 minus x squared to the negative 1 third. Or negative 4x over 3 times 1 minus x squared to the 1 third here. And that'll be my final answer. You can even put in radical, even though I don't really care about this part. You can say it like this or like this. I think this answer is good enough because you can evaluate the slopes at x equal to whatever. So yeah, so that's gonna be negative 4x over 3 times 1 minus x squared to the 1/3. Is this okay? How many of you guys got it right? Okay, good. How many of you guys got it wrong? And raise your hand. Okay. Nathan, can you tell me what you did wrong?
Started off way off.
Okay, what did you start off?
I put the whole thing on over 1.
Why is it over 1 though?
That would be a negative exponent. Yeah, that'd be a
Nathan,
negative
can I see your
exponent.
paper? Give me your paper. Yeah, let me see what.
I mean, I figured it up a little, but it kind of doesn't really up where I am since I just forgot that I can't.
Wait, where is it?
Bottom.
Oh, okay. Tutor. Wait, 1 second. Oh, it's not. Yeah, it's not. There's no exponent rule can move down the bottom. If it's a positive exponent, you cannot switch. This only if it's a negative exponent. So let's say it's 1 minus x squared to the negative 2/3, then you can switch like this. Okay. Dania, can you tell me where you make a mistake? Why stop?
Yeah.
So, what's wrong being wrong? And if you're wrong, you stop.
Well, because I was myself, so I just wanted to see how you did it first. And
Okay, that's fair. Yes, Narang.
I did the same thing. I stopped because I thought that was the final answer. Like, you know how in the above question you didn't distribute the 3 to the other stuff, but how come for this question you did?
Oh, for distributing
Like,
the 2x and
the-
okay, so technically, if you got to here, this answer is already correct. Okay, that's fine. If you got to here, it's correct. But I know that this 2 is just can multiply together to make it better looking, but it doesn't have to.
okay.
But let's just say if I want to find the slope at x equal to 4, then I can plug in x. I can plug in 4 here already, so it's not a wrong answer. I can still find the slope over there. So Daniel, where do you stop?
I stopped.
Here.
Yeah.
Okay, so you forgot to take derivative inside. So derivative inside, derivative outside. Derivative outside first, and then times derivative inside. Yes, Ian.
My script was pretty simple. I accidentally wrote -2 instead of -2x.
Yeah. Okay.
When
So
I drifted, I got rid of the x because
So I would say this is even though he says the keyword he says simple mistake, but it's not simple mistake.
no mistake.
It's not a simple mistake, right? Because if you do that on the test, I'm still gonna take everything out. Why that's important? Because you have to realize your mind has to be very disciplined on not making those small mistakes. Like those of you guys play tennis, you know, right? If you play tennis, you don't want to make enforced error. So what you go is just make sure you hit the ball, you serve the ball across the net. Right? So sometimes people think ours is like simple mistake is not big deal. Like for example, Lena playing golf, right? Would you rather miss a 25-yard shot or you rather miss a 2-yard shot? 2-yard shot is a simple.
None of them. These are so easy to be on a green. Why would you miss 2 of them?
No, I'm saying that if a 2-yard, if you 2-yard to the hole, there were some people miss that. There were some people miss the 2-yard shot. Yeah, like the putting. Yes, those people miss the 2-yard shots. But if I were to choose, I'd rather you miss a 20-yard shots than 2-yard shot, even though 2-yard is so simple. Do you see what I'm trying to get to? It's, you know, it's the same thing. You don't want to miss those easy ones. Hard one, I'm okay with you to miss. But those are the simple ones that always get you. On SAT, same thing. In SAT, the hardest question in module 2 and the second last 2 questions are so hard, like even I have a hard time. I'm okay you can leave those 2 blank. I'm okay with you got those two wrong because Anthony, Jared, they all got those wrong. And they're very, very smart. They got 790, but I'm okay with 790. I'm not okay you mess up on the first module on the question 3 because that could be like y equal to 2x plus 5. What is the slope? And if you got those wrong, you thought it was 5, then guess what? That's major mistake because the simple one's actually the major one. So don't make the simple mistake. Okay, so let's talk about when do you avoid quotient rule. We did it on the last test. Can you tell me 3 situations you should avoid quotient rule? Yes, Ian.
The bottom is a monomial.
Okay, so not only that, it's a polynomial
Over a monomial.
over monomial. Okay, so that kind of apply 2 situations. When polynomial over constant. Constant is still monomial. So over constant is also true. So this one you can use the power rule. You can split them up and use power rule. The third situation that we didn't actually see it yet. The third situation is a constant on top and poly on the bottom. So let's talk about first situation. First situation is like this. Square root x minus 1 over root x. If I want to take a derivative of this, I just
Square root over square root.
1 minus x to the negative 1/2. I split them. And I take a derivative. It's going to be 1/2 x to the negative 3/2. And that's it. I'm done. I split them. Same thing as this one. If I have square root x minus 1 over 2, I can split them. So it's 1/2 x to the 1/2 minus 1/2. If I take a derivative of this, it's going to be negative 1/4. No, positive 1/4 x to the negative 1/2. And I'm done. I split them. I take a derivative. Now this situation here is different. How about 6 over 1 minus x squared? This is constant on the top, polynomial on the bottom. Now constant on the top, I will avoid quotient rule because I can apply this in different way. I can use product rule and chain. So I can move this up to -1. Does that make sense? Then I can use product rule here, and I can use chain rule. No, I can use not product rule. If I can just use chain rule. There's only one rule involved. So there's 1 layer. There's 2 layer. So it'll be 6 times -1 to the 1 minus x squared to the -2. Is that okay? Times derivative of inside, which is -2x. So in this case, I can multiply everything outside here, which is gonna be 12x over 1 minus x squared. Much easier than the quotient rule I had to deal with. I just use chain rule. I boom up, I use chain rule. Now I'm gonna ask you to try one. Hold on a second. 3 minus 2x to the 4, 3 like this. I want you to take a derivative of this. Now, if you realize I have a constant on the top, even though on the bottom it's not polynomial, but it's still similar. Maybe you guys are not done. Okay, I'll keep on finishing.
Yeah. Because I'm not synchronized that, and he said that was technically far out.
Why'd you bring that up?
Because this to the 3/4 derivative. We got the derivative.
It could be negative 3 over.
Negative 3/4.
Yeah. It's over.
No, it's not over 7. You got rid of one in the first part. The entire thing's -1 to the whole thing. First part.
Okay, shh. It is -3/4
God damn it.
because this one is gonna be 3 minus 2x to the 3/4. Now remember, I cannot take a derivative at this moment unless you use quotient rule. So if you want to do it with a chain rule, you have to move to the top. Does that make sense? That's equal to -7 to the 3 minus 2x to the -3/4. Now you have to take a derivative. There are 2 layers. One is the first layer here, and second one is the second layer. Ashton, is this okay? Okay, so now I'm going to take a derivative here. So I'm going to write down y prime. Do you realize I do y and I do y prime so I don't confuse myself? So it's going to be -7 times -3/4. The first layer is going to be black. And then that's going to be 3 minus 2x to the -7/4. Is that okay? Times derivative of the inside, which is the blue layer. What's the derivative of the inside? -2. So then, therefore, is negative times negative times negative. Well, 2 and the 4 can cancel. That's going to be 2. So that's going to be negative. So it's -21/2 times 3 minus 2x to the -7/4. Or -21/2 times 3 minus 2x to the 7/4. So is this okay?
Is that 21 or
21.
You only technically need to get the butterfly prime, but the rest of it just.
Narang, did you get it right? Yeah?
But so do you have to bring it down to the bottom?
No, you don't have to. But when I want to evaluate something, let's say, for example, if I want to find out when x is equal to 1, I want to find out the slope. It's much to do like a positive exponent rather than negative exponent. Is this okay? Okay, let's do this one. Now, before you do it, I want you to look at this question. I want you to look at this question. Okay, before you start, always survey the questions. So what I mean by survey is to think about what kind of things you have to do. Kind of have a brainstorm, think about what you're supposed to, how many rules I should use, and how many things you have to do. So as a good student, when they do math, they don't jump into the problem. They actually kind of pause and they think about it for another 30 to 40 seconds. Usually good students kind of don't jump into writing unless they are super quick at pick up stuff and they just understand the first time. But sometimes good student is take some time to look through, see what kind of rule I need to use. So before you start, I want you to think about what kind of rule you have to use and how many times you have to use them. Oh, by the way, I want to find horizontal tangent here. Find horizontal tangent. How do I find horizontal tangent, by the way, from the last test? Slope equal to 0 or derivative equal to 0. So, okay, good. So the thing is now, do we know how to take a derivative? Yeah, you know, you don't want to expand this and compress this. No. how many rule you have to use and how many times. That's what I'm gonna ask you first before you jump start. Chase, what do you think?
These two rules, but you just chain rule twice.
Perfect. Okay, now I want you to try to do them. But don't make any simple mistake. Remember, every simple mistake is going to be an easy mistake. So he was right. There was product rule first. And each of the things that go into multiple power other than 1 is going to be a chain rule. Did we talk about when? Hold on a second. Let me. Did I write down those? Yeah. So when a parenthesis other power than 1. So this is other power than 1 because you guys 3 to 4. So I want you to take a derivative. Don't worry about simplifying, but take a derivative correctly. Okay, let's take a derivative of this. So first of all, they are product rule. They are this, and they are this. Do you see the blackened? Right? So they are two functions multiply each other. So what we're gonna do the red first. So the red is gonna be take a derivative of this. It's gonna be 4 times 3x minus 2 to the third. Now, did you forget multiply by 3?
No.
Okay, that's a good start. Then I'm gonna leave the 2x minus 1 to the third here. I'm a plus. Is this okay so far? Is this okay so far? Now I'm gonna leave the first one alone, so it'll be 3x minus 2 to the 4th power, and times by derivative of this one, the black one here, so it's 3 times 2x minus 1 to the 2nd times derivative of the inside 2. Now you can do it the other way. It doesn't really matter because they're addition. It doesn't matter 3 plus 4 or 4 plus 3. So it doesn't matter which way you do derivative of. My habit is always take a derivative first on the first term. It's not lefty right, righty left. It's actually the other way around. But it doesn't really matter which way you did it, long as you have the same thing. Now here's the hard part. Is how do I find the horizontal tangent? At this moment, I cannot find horizontal tangent yet because it's not in the factor form. I'm going to factor out GCF here. So it's going to be 3x minus 2. Now, between 3 and 4, which one I should factor out? Why 3? So the rule is to always factor out the most negative. That's 3. And also, this one here is 3. And here, I'm going to factor out the most negative. So it'll be 2x minus 1 to the 2nd. Is that okay? Now, I'm going to put a bracket here. What do I have left? I got 4 times 3 is 12. Is that okay? Times, what's left? 2x minus 1, I think. Plus, 3 times 2 is 6. And if I factor out 3, then I got 3x minus 2. I'm almost done there. So it'll be 3x minus 2 to the third, 2x minus 1 to the 2nd, times 24x minus 12, plus 18x minus 12. Is that okay?
Well, you can simplify the right side.
and that's gonna give you a 42x minus 24 times 2x minus 1 to the square times 3x minus 2 to the third. Now you got x equal to 2 over third, x equal to 1/2, that's a horizontal tangent, and x equal to 24 over 42, which is x equal to 4 is gonna be 6 over 7. No, it's not. It's not divided by 4.
That'd be 12.
12 over 21.
Which is divisible by 3, so that'd be 4 over 7.
4 over 7. Thank you. I can't do my math.
Feedback.
Oh, what's your sheet?
Oh, here it is.
Today you're doing good. So I'm based on today. Today is an A. Today.
Of adrenaline and pain.
Okay.
And
Whatever it works, hopefully you do your homework the same way.
also, I just have to. This is very. The terms of the blender, you like mix them to. You said that there's like algebraic, and then there's the one where you look at the graph, and then there's the one where you mix them.